Hi, this is Chris Schomburg, your instructor, and today we're going to learn about how a photocell works. Now, photocell is actually what it's called in your lab manual, but here this is actually called a photoresistor, and really that's actually what it is. It's a variable resistor that changes with the amount of light that is present, which is pretty impressive. It's kind of a cool device. So what we're going to do is we're going to hook this one up, and then we'll draw the schematic, and then we'll actually look at the circuit symbols for it, and that's pretty much it. This one's pretty quick, and it should be something that we should be able to do. So I always rotate these guys. So I'm going to rotate the board so it's vertical. Okay. I'm going to also rotate the 9-volt battery. I'm going to place it right next to my breadboard. Now I always put in the positive first, and I always kind of put it at the very top rail. I'm going to turn that to red because that's the high input or high 9 volts coming in. Then I'm going to go up a little higher, click, and then go all the way over and go into the top rail on the other side, which then is black. Okay, so now I have 9 volts coming in and the ground coming out right there. It's not a complete circuit yet. We have to make a complete circuit. So the next thing I can do is that I know that the round part of this guy is positive and the flat part is negative. We've talked about that several times now. So what we're going to do, oh, I rotated too much. Okay, is go like that. So I'm going to go ahead, and this guy is in the way. Okay, there we go. Huh. Still in the way. Okay. Well, I'm going to rotate it like that just so that we can look at it. Okay, I'm going to put this, again, I'm probably going to put it in later instead of A or D. This is way in the way. Okay, so this one I put it, basically, I could put it in D. I'm actually going to put it, yeah, D looks good. So D, 1 and 2. So 1, D, is actually the power to the high input. So I'm going to put a jumper wire right to there. And again, that's going to give us our full 9 volts. So I'm going to go red right there. Okay. Now, in between, I could short circuit it, and we've done this many times. I could short circuit it and go directly to ground, and again, that would give us such a high reading that it would probably burn up the light or burst the light. So we don't want that. So we're going to put our photocell in between here. So I'm actually going to put the photocell, and I'm going to rotate it because I don't want it shorted. Okay, so I'm going to actually put it like here, and so then I'm going to take, let's actually put it a little bit further over, kind of like we did the other one. So I'm going to put it in G, 1 and 2, and so then I'm going to take E2, which is the ground pin. I'm going to go to here. Okay, now I'm going to leave this one orange. Why I'm doing that is because it's going to be a little bit lower voltage because we have a drop in voltage going through this light. Anytime it goes through something that actually does something, it's going to reduce the voltage. It might reduce the current, not necessarily, but it's going to reduce the voltage or the current. And so the key thing here is that I'm indicating this is 9 volts, this is lower than 9 volts. And so then what we're going to do is we're going to take this and we're going to go all the way to the black rail. In this case, I'm going to consider this one black because it's going to be going down to the low setting. Okay, now we can actually start it. So if we start this, we actually do see some light. What's cool about this, though, is I can click on this and actually put in more light. The more light I put in, the smaller the resistance. And how do I know that? Because, again, we talked about this earlier. This basically is just like your potentiometer, but it depends on how much light instead of how much you twist. Instead of how much you twist, it's how much light is actually present. And so the more light that I have, the lower the resistance and the brighter the bulb. And the less light that I have, the dimmer the light, the dimmer the LED. Now you could start thinking about, okay, what are some ways and methods of why this would be used? Now, the way it's built here, there aren't that many methods for it. One thing I've heard people do is make an alarm off of it. So when it starts to become really bright outside, it then plays an alarm and wakes you up. Okay, so that could be something that could be done just through this simple circuit. Instead of putting in a LED, you would put in the alarm right there, and it would work fine. But the more typical use of this guy is actually to have an inversion. So if you thought about it in a little bit different way, if I inverted this, so instead of when it's dark, then it's bright, and when it's light, then it's dim, that would be an inversion. And if you think about it, if when it's dark it's bright, that would be perfect for like walk-in patio lights, and they use them all the time. They're called LDR circuits, and they're actually used all the time. So this is close to something that is an industrial standard, and is something that is used for a lot of lights going into businesses, commercial buildings, industrial buildings, and residential buildings. And what they do is when it gets dusk, all of a sudden it turns on the light, and when it gets bright outside, it turns off the light. So it uses it when it needs to. This is kind of a cool concept because this is leading into the big concept of basically how solar panels are meant to be used. You generate electricity during the light times, and then you store it so that and you can use it in a battery later or some other device. Okay, so that's the basic concepts. This one does not take us very long to build. Really, it's a special kind of resistor. It varies the internal resistance according to the intensity of light which hits the surface. The more light that shows on the photocell, the lower the resistance it will have, and the more electrons can pass through it. As the circuit in this experiment is made up of components, a battery, an LED, and a photocell. They're connected in series, and one following the other, like a daisy chain. The current flows from the negative terminal of the battery to the positive terminal of the battery, passing through the LED and the photocell as seen in the schematic. So let's go ahead, let's take some time, let's make the schematic. So I'm going to actually pull out my mouse, and I'm going to put in my tablet. And if you're curious how I'm doing this, I can show you in a second. This is actually a graphics tablet, so it is used for art, but I'm using it in this case to draw your schematics. So this is the pen for it, and we're going to go ahead and we're going to click down here. And I'm actually making a snippet, so it's actually it's a picture of what I'm working on. There we go. And so then what I do is then I can draw. There we go. So then I can draw right here. And so this right here, we see right here is the battery. So we're going to draw the battery first. Again, we always start with I have a funny color, so let's go ahead and go back to a really standard color here. There we go. Okay, so if we go long, small, long, small. And this right here is the positive terminal. This right here is the negative terminal. Okay, and we go up like this, and we go over here. Now, the way I have it drawn here, we're going to go ahead and we're going to put this guy in here. Oops, I didn't draw that real well. Okay, here we go. Okay, so that looks like that. That's a LED. This is my battery. Okay, and then again with the LED, what we want to indicate is the light is going out of it. Okay, and then the next thing that we're going to put in, and I apologize, it didn't line up there. Okay, the next thing that we're going to put in is the photocell. I just drew a resistor to start out with. It isn't a resistor, But then what you're going to go and do is you're going to put a circle around it, and then you're going to also put in an arrow going in. Arrows going in. Okay, so this then is our photocell. Okay, so we have our battery, our LED, and our photocell, and that is basically the schematic that we need for this specific diagram. So I'm going to go ahead and I'm going to label this. And really these are symbolic. Okay, that's a symbol schematic, and then this guy right here is actually something different. So what we're actually building right here, we call this assembly. Okay, so this is actually our assembly diagram, and so this is actually how we would build it. So this is like step-by-step procedures how to build it. This is the symbolic schematic, and this is actually what you would do if you were doing an industry. You'd send in this thing. Okay, so let's just compare. Again, I do this every time because I think it's powerful. So we're gonna go ahead. I think I did this in like a beige last time. Okay, so right here, this is our battery. Okay, and then this right here is the symbol for the battery. Okay, this is the positive, this is the negative, this is the positive, this is the negative. Okay, so let's go to another color. Alright, so here we have, this is our LED right here, right? And then this right here is our LED. Okay, this is the positive terminal, this is the negative terminal. This is the positive terminal, this is the negative terminal. Okay, remember the flat side is negative, the round side is positive. Okay, and then let's go ahead, let's go to the photocell. This is our photocell here. Okay, again, it doesn't matter which direction this is hooked up. It is unidirectional. It is either way will work. And so this is the photocell. Again, if I were to draw it this way, this would be the positive side, this would be the negative side, and so we go from positive, negative, positive, negative, negative, positive. There we go. So essentially that's how it works. Okay? And we'll talk a lot more about that when we get to Kirchhoff's laws, but for now, we just have the colors and they're basically what each element is. Okay, so I hope you enjoyed this lesson. We'll actually talk more about other circuits to come. The next element of the circuit that we're going to actually talk about is the capacitor, which should be really fun. So I hope you really enjoyed this, and I hope you had a chance to actually try it for yourself.